When we do a mini workshop like this, we're talking about some things that are sort of skim off the top here. There's no way in 30 minutes I can cover the mechanical engineering you're going to need. We do more extensive work during our specialty workshop, which is 2.5 days in January. But I need to let you stick your toe in the water here and see some of the considerations you need to think about. Whenever we started, and I built 9 different solar cars with teams over 20 years, we always did our research. We looked at what was out there. What did we want to do? 2, what were we capable of doing? You look at some of the great cars that race in the World Solar Challenge. Could you do that? Could you build it? Are you capable right now of building it? What are you capable of right now? What are your skills? Then you have to make some very basic decisions from the beginning. And the decisions you make, you can't go back on later on because you start building on that decision. First decision you may want to make is, am I going to be 4-wheel or 3-wheel car? A lot of teams like 3-wheel. You save weight. But the problem is, if you have a skunk in the road, one of your wheels is going to hit that skunk, and you're going to take that for 100 miles with you. And that driver is not going to be real thrilled. You also have to have a suspension large enough in the back to be able to handle the weight of that, including your batteries most of the time. If you have a 4-wheel car, then you've got greater stability in the event of a blowout or a malfunction. We were driving across Australia, and the front suspension on the left-hand side gave out. But I had 3 other wheels to keep us up. If we hadn't had those 3 other wheels, we might have been thrown into the line of traffic. So that's a consideration to think about. Depending upon the type of wheels and tires you're using, it's not that bad of an investment to go that route. Then you've got to think about, what kind of motor am I going to use? Because when you decide your motor, then you decide what are the best voltage to operate that motor. The spec sheet that Joel was talking about tells you this motor operates best at 36 volts or 48 volts. If it operates at 36 volts, then you know how many batteries you have to have. Once you know how many batteries you have to have, then you know how many solar cells you have to have in order to be able to put the voltage into the batteries. 36 volts means your solar cells must be putting out 42 to 46 volts. You've got to have more coming in from the array into your batteries than just the even amount. So you see how the decision you make, what motor, what batteries, what solar cells, sort of comes along that line. If you start saying, well, I'm going to get this kind of array, well, that's great, but will I be able to take enough energy in to operate the batteries? Think about this as a progression. When you plan your project, think about the decisions you need to make and when you have to make them. So we're going to talk about mechanical engineering sort of off the top, skim off the top here. And we're going to look at it, materials, the roll bar and crush zones, suspension and steering, and wheels and brakes. So with materials, mild carbon steel is not that bad to use. It's about the same weight as some of your aluminum, depending upon its thickness. And the value is that almost everybody can start welding that and cutting that and dealing with it. I had an old team out of New York who swore by the importance for a new team to use square tubing for their car, because it's easy to take one square tube and weld it to another square tube. If you're using round for your car, then and you mount it with another one, you've got to miter in your curve in there so it'll fit properly. So you're thinking about the skills of the person who's doing this. Can they handle that? Sometimes your steel is heavy, but maybe not that much more, and it may be worthwhile. Easily to modify. You can cut something out and refix it. And you've got all kinds of varieties. Here's a car that's made with your carbon steel. Another type of frame can be made with chromoly, which is a more sophisticated, a little bit more expensive material to use, but it's lighter weight, easily modified, changed, comes in large varieties, If you can find a supplier in town that deals in chromoly, go to them and do what Joel says, ask them for a donation. They may not be able to give you money, but they probably have some materials left over from another project which they can donate to you. So chromoly builds you a lighter car, but it's still strong. What about aluminum? Many cars are built out of aluminum. Stiff in its weight, harder to weld, generally tubular, has a resistance fatigue to it, which means it tends to, at some point, start wanting to give on you. That's where you bring in extra pieces of aluminum, you duct tape things together. We were going across Australia at an earlier time with a car where the aluminum tube was bending so much, we had to duct tape other pieces to it because of the fatigue. But it is what many of the teams will use. And it can be difficult to repair unless you have duct tape. Carbon fiber. Now, many teams will start building this, and Joel is the expert on this because they actually built their most sophisticated car using carbon fiber. You have to learn the technique. This is not a first car project. It's after you're a little bit more sophisticated with what you're doing because it's a major thing to build out of this. And once you've built a composite material frame, you can't easily fix it. It's there. You've got to have planned ahead where your batteries are and all that kind of thing. It's expensive, careful planning, hard to repair. How about building the frame itself, the roll bar and crush zones? We've changed our terminology. Instead of having a roll cage, it's now a safety cell. And this is a rigid protection encompassing the entire driver. And it's a minimum of 5 meters clearance to the driver. So your safety cell has got to be from every driver 5 centimeters from them. So you've got a little wiggle room. And if something were to bend, it's not going to bend into your driver. Your crush zone is a structural component designed to collapse. So you're going to be using a lighter weight material for your crush zone. This is a good example of how you got a safety cell here. That material is not going to give way. See how it protects the driver's shoulder and head? But look at all of this crush zone that'll give on each side, designed to give. And then your roll bar protects your driver in the event of a rollover, made out of one single piece, and every driver has to have 5 centimeters clearance from the head to the bottom of the roll bar. That's so if you're flipped upside down, your head's not touching. So that's just designed to help protect you. Here's some good examples of that roll bar. You see on the left your sufficient vertical clearance. And notice a continuous piece of metal side view there. That makes a good roll bar. And you notice that they've got this additional member added on here. That way that roll bar is not going to collapse. That's really an intelligent way to handle your roll bar. Your crush zone, designed to absorb the impact of a collision, protect the driver from the front, side, rear collisions. You have a minimum of 15 centimeters of horizontal distance from all parts of the safety cell. This is new. If you're building a new car, it needs to comply with this. From your safety cell to your crush zone, it's got to be 15 centimeters horizontal distance from the parts to the safety cell. That means it's going to be able to crush in that much before it gets to the safety cell. In 2025, it's going to become more rigid. But if you're building a new car now, you need to follow the guidelines. If you raced in 2022, then you can be grandfathered into using your old car until you build your next car, which is before 2025. But this is designed to build more safety in it. Your crush zone is designed to absorb impact, protect the driver, and most importantly, during scrutineering, your team must be able to demonstrate a specific, adequate crush zone in order to compete. Your team has to be able to do that. Here's the new drawing. You can see here, this is the safety cell. Here's the crush zone. And notice the crush zone has to be up 30 centimeters now. So if somebody's driving towards you from the side, there's something going to intercede between them and you. We've actually had cars in the old times where we used to joke that you could drive an 18-wheeler through the side of the car and never touch anything but the driver. So we want to make sure that there's something that's going to be able to absorb an impact. Do we think there's going to be an impact? No, we don't. But we've got to prepare. We've got to make you the safest we possibly can, because you never know what's going to happen. So here is additional drawings here showing the roll bar. Now this should be saying safety cell, crush zone. This is an interesting example. It does have a crush zone, but the crush zone's made out of the same material as the safety cell. That doesn't work well. We want this to be able to give way in the event that you are hit from the side. So you want to use a lighter weight material on the side, or with your crush zone. Okay, let's talk about suspension and steering. Common suspensions are a McPherson strut, the single A-arm there. You've got your solid axle. Interesting, our first car we ever took to Australia had a solid axle. It worked fine. Of course, by the time we finished, the car had so torqued that we could never use a frame again. But it worked. And for a new car, our first car, we were just proud that it was able to get through with it. And then you've got the double A-arm, which seems to be sort of a favorite of solar cars because it makes the steering and the math that it takes to put this together more sophisticated. Notice the diagram there. We'll go into steering geometry in our January workshop. I didn't want to touch on that because if I throw that at you now, you'll get too much glass eyes here and people wondering about that. What you're thinking about with your wheels and with your suspension is what part of that wheel is going to touch the ground. You want to minimize that rolling patch so you have less friction. So the better your car is set up so that it has a proper camber and caliper here, you're going to be in good shape. What about wheels and brakes? To me, I like a lighter weight wheel. The problem with a lighter weight wheel is sometimes you're going to have more blowouts. We got real sophisticated. We used some of the fancy wheels that were used by some of the college teams. I think, Winston, you had some of the old wheels, and that required about a $100 tube to go on that wheel. And if it was not properly aligned, you'd lose your wheels. And one of our first races at the Speedway with that wheel, in one session, between 9 to 12, we had 9 blowouts because it wasn't properly aligned. Larger wheels seem to be easier to line, less blowout. They're more durable. But then you're carrying more weight, and you have a bigger patch on the ground, and that creates more friction, and that reduces your capacity to drive at a faster rate. Here's a 4-wheel design. Again, the idea is that it gives you better protection in the event that you have a blowout. It's required for the cruiser class. Here's that fancy wheel that's milled aluminum that was used by some of the college team. Or you can get something that's filled in. I recommend something that's pretty well supported so that you're dealing with the lateral stress as well as the vertical stress. And that's what many teams forget about. That's why many teams, I don't use bicycle tires, wheels. Because bicycle wheels are not intended to be stressed on the side. They're meant to be stressed vertically. But a solar car, when it goes around the corner, puts huge stress on the wheel. So you need to have the material that wheel is composed of capable of withstanding that stress. That's why solid wheels of some sort seem to work well. Or if you're using a heavier motorcycle tire or hot rod tire or something on that line that's got greater support, you'll be able to take care of that. You don't want to change your tire, particularly if you're on a cross-country race, because you don't know what kind of environment you're going to be. Am I going to be having to roll the car off into the grass? Is the grass what is in the grass? Are there fleas? Are there ticks? Are there snakes? Whatever it might happen to be. Luckily, we do our best to try to make sure that there's a good shoulder on the side of the road so you have some room there. But you just never know when you're going to have a blowout. Here are some varieties of larger wheels that seem to work well. Your brakes, you're going to need 2 separately operating brake systems on the car. Each is going to have a separate pedal. 2 separate operations. You can't tie the 2 brakes together. You've got to have a separate pedal for each one. You cannot use a motorcycle brake. You cannot use a bicycle brake. It's got to be a foot pedal type of braking system. You can't use something that you printed out in a 3D system. It gives way too quickly. We found that out this year. We need something really substantial. So when you hit that brake, that's your brake. Because of experience, one of our first cars, we were required to drive across battery park in New York area on the soul. And the driver said, the judge said, drive this as fast as you can to get the brake. So we drove as fast as we could to get the brake. And the well broke and the brake mechanism, the flying taxi driver on the car. The car was going 35 miles an hour. And I had 20 kids running around the suspension. We needed a second braking system. So my braking system's going to work. Yeah, it will work if you have a backup. So you've got 2 systems. Does it always work? We had a minor collision between a car and another car on the track several years ago. And I asked the person who was driving, I said, did your second brake work? And they said, I'm not pushing. So they're both there to help you be able to keep your car under control. Many teams will use a hydraulic system, although an actual physical brake works, except you can't throw an anchor out the back of your car. And a foot brake doesn't work. This is a picture showing a not able to use this anymore. You see the EXO across it. Here you had one pedal that operated 2 systems. Can't do that. You have to have 2 separate braking systems. And then you're going to have braking tests that are going to be pretty sufficient. We have a, can you drive at a certain speed and have your car come to a stop? Are you able to control it? And then we take you out on the track and you do as fast as you can, route around the track, and then hit the brakes. Does your car maintain control? If it fishtails, it means that you're not able to control it. So trust your car. This is all about trusting. One of the things that I know that the Arkansas stress, make sure your car is working when you get into the race. You don't want to have to try to rebuild your car because you need those 3 days So that's our mini look at this. I to talk about his experience in mechanical engineering and share his interesting comments here. He is the advisor of a prosperous organization.
Thank you. All right, so let's see. I have a couple of advantages here when I was doing this. One of them is I'm actually a mechanical engineer, so that helps. The second one, when I thought about let's do solar car challenge, I called Dr. Marx and Dr. his wife things that, you know, the best way to learn, come and be a judge. Am I right, Dr. Marx?
That's right.
Yeah, and it is true. Like Joe was saying, you don't see that side when you're a mentor because you don't get to see any scrutineering. But when you're a judge, then you start looking at how all these cars are built and what are the people are looking at. Okay? So I want to stress on Dr. Mark says, let's make sure that the car is built. I will say, let's make sure that the car can pass scrutineering before you get there. It's not a secret. They don't keep it quiet. Everything that you have to go through scrutineering is there, is written. You can test it, everything. and double test it, and if you test it and then you make a change, test it again, okay? It has to be robust. We actually test the car in an accident. So we broke a tire. We thought the guy was a little bit more aggressive in doing a slalom, and he managed to brake to turn apart one of the wheels, and the car tilted. So we know at least the structure, the rest of the car was good. We have to change one tire, all right? And after a while, it was a joke. At the moment, it wasn't, you know. But it was good. Mechanical side, we need to measure everything. Like you all said, 8th grade, that's the same philosophy I have. Everything is 8th grade, no matter what, you know. It's not that much more expensive to do it and keep everything straight. It has to be 8th grade, the nut also, okay? And sometimes I don't know why, the same place where you're buying the 8th grade bolt, they give you a nut and those are 5th grade. So make sure that you can prove that those nuts are 8th grade, and you will have 3 little dots on the sides of the nut, and that's part of the scrutineering. So far, we have passed the scrutineering on the first day every time we go there because we know it's going to pass. We have a tilting of the car. It's scary, but you put the jack on that car and you will tilt it and make sure that nothing breaks. And you do that also at your garage. If it breaks, it's a lot easier to fix it there. All right? I know we want to compete, we want to win, all right? But this is going out, I guess. But the reality is, you need to set what your goals are, all right? And your goals should be, go there and pass the scrutineering. Our first car also weighed over 1,000 pounds. I think that's typical on all the cars around. One sort of measure. We want to keep it in place and we overbuilt a little bit. Or we don't have the money to buy for volume, $4,000 worth of volume or anything like that. So brake, it has to be brakes that you put on the wheels only. It has to be how solid is the pedal when you put it there, okay? If you put in the pedal in a way that is on the floor and the floor flex a little bit, you're not going to be able to brake, okay? You need to have that very solid. What else? Make it out of steel, first one around, all right? And then you learn. Even if you make out of steel, you can still go back and keep drill holes on all the structure and reduce the weight. All right? You can reduce the weight without compromising the structure of the car by drilling some of those elements there out. All right? I don't know, I'd like to answer some questions. I know we're ready to go to lunch very soon. What question you have? What are you guys plan already what you're going to build before coming here? What's the plan on the rookie people?
Maybe they're going to wait until after we do our presentations and then come up and make those decisions.
Yes.
That would be the smart thing.
I hope it's changing. That's what I was going to. I hope that has changed a lot after this presentation on how you're going to build, what you're going to build, okay? Any questions here?
Prosper Solar, thank you for
All right.